Okay, now I'll teach about orthogonal rake system. Before that, let me first explain you about speed, feet, and depth of cut. In turning operation, we know that workpiece is rotated and it is cylindrical in shape. And what is the speed? Speed. Speed, cutting velocity, or speed is the cutting velocity or speed that is denoted by letter VC. It is the rate of rotation of spindle, rate of rotation of spindle where the tool is held. This is the cutting velocity VC. It is always in RPM, rotation per minute of the workpiece, This is your speed. In terms of formula, VC is always equal to pi d n by 60 into 1000 meters per second, where n is equal to revolution per minute. It's RPM, we say it is in revolutions per minute, number of rotation of the workpiece per minute, and D is the capital D is equal to, we know that cylindrical jobs are used for turning operation. It is the diameter of workpiece, dia of workpiece in mm. In mm. So that's why we are dividing 1000 to make it into meter per second. So it is actually VC is equal to pi dn by 60. So this is the speed. And every time when we deal about the turning operation, we say about the feed, and depth of cut. Feed, I denote by symbol smallest 0. What is feed? It is the rate at which the tool moves into the part. Means we know that it's a cylindrical tool. We have to turn from the starting end to the up to the end along the longitudinal direction. So longitudinal direction, initially the x is 0 and it has to move from x is equal to L. So it is in longitudinal direction. So what is speed? The rate at which the tool moves. Because initially you know that here it is the workpiece and here it is the cutting tool. This is the tool. The tool has to travel from this point to along this length L. So what is speed? It is the rate at which the tool moves into the workpiece. It is in always in mm per revolution. This is speed. And third is the depth of cut. Depth of cut denoted by small t. What is the depth of cut? Depth of cut, how deep the tool cuts into the workpiece. See, we have to reduce. See, while turning operation uh, along this thickness, we are along the diameter wise also we are reducing the thickness, as well as it has to move from L is equal to 0 to X is equal to 0 to X is equal to L. So depth of cut is along with this diametric circumference of the tool. So depth of cut is the how deep the tool cuts, how deep the tool cuts into the workpiece. So, and everything in the turning we know that turning operation takes place by using a lathe machine. The lathe machine, we have to initially set the depth of cut, the speed and feed. What is N we are setting, what is the feed rate we want, what is the depth of cut we needed. Ultimately, we get material removal rate, MRR. So, MRR, that is the material removal rate, material removal rate, MRR. MRR is in mm cube per second for one revolution. So, what is MRR? MRR means MRR involves all the three terms VC, speed, feed into depth of speed, feed, it is your F0, this is into T. VC into F0 into T. So, this is the material removal rate of any process. And we know that, and if we take the unitary method, I think if we take if you want to know its units, you can take the unit method. Unit of, you can put unit of VC, you can multiply it by unit of F0 multiplied by unit of depth of cut. So all if you multiply, you will get mm cube per second. So, this was all about speed, feed, and depth of cut. And now I would like to start about this ORS system. Like in ASA system, we had three axes and three planes. First one was the reference plane. Reference plane is always the plane which is perpendicular to the velocity vector is known as reference plane. Here also in ORS system or orthogonal rake system, ORS. ASA system is used for manufacture of tool, and for practical application and machining purpose we use ORS system. So here in this case, this is the cutting tool, and I have told you there are two edges. One is the principal cutting edge and other is the auxiliary cutting edge. And principal cutting edge is always longer than that of the auxiliary cutting edge. And this is the reference plane pi r, as it is always perpendicular to the velocity vector vc, and z direction always lies in the direction of vc. And this is the principal cutting edge. I'm writing in terms of PCE, principal cutting edge of the tool, and so obviously this side is the auxiliary cutting edge of the tool. Okay, now regarding the plane. Okay, suppose let's say this and this is the nose radius. Why nose radius is provided? I think I have told you. Nose is a point where the principal cutting edge and the auxiliary cutting edge meets. Nose radius, it improves the tool life as well as the surface finish. And if we provide too large a nose radius, then it will produce shatter or vibration in the machine and setup. Now, this is the pi r plane, and here we can see that this is the principal cutting edge. So this principal cutting edge gives us plane pi c, that is known as our cutting plane. Pi c is the cutting plane along y-o axis, and here and here, and another plane comes into picture, that is the orthogonal plane pi o. Pi o is the plane pi c and pi r. Pi r is the reference plane perpendicular to the velocity vector, and pi c is the plane or the cutting plane. Cutting plane is perpendicular to reference plane, and pi o is the plane which is perpendicular to both pi c as well as pi r plane. And this is the axis xo. As it is an orthogonal system, we are using xo, yo, and zo. And planes are pi r, pi c, and pi x planes. So planes Number 1, reference plane, reference plane, reference plane pi r. Number 2, cutting plane pi c, cutting plane pi c. Third is orthogonal plane, orthogonal plane pi o plane. So these are the three planes. But what is reference plane? Same as earlier in ORS system, the plane perpendicular to velocity vector vc. What is cutting plane? Plane perpendicular to reference plane pi r, and it contains the principal cutting edge. You can see that, and containing the principal cutting edge. What is pi o plane? Plane perpendicular to both pi r plane and cutting plane, perpendicular to pi r and pi c plane. So this is the orthogonal plane pi o. And what are the axes in orthogonal system? Axis. Number 1, xo axis. Number 2, yo axis. Number 3, zo axis. Xo axis, it is the intersection of, you can see that, intersection of pi o plane, intersection of pi o and pi r plane. So that is your xo. Xo is the intersection of pi r and pi o plane. Yes, I'm just get to. Yes, I got the question now. Intersection of pi r and pi o planes. Likewise, what is y axis? It is the intersection of pi r and pi c plane. Intersection of, you can see that, pi r and pi c planes. Pi c planes. What is zo axis? It is the direction of, in the direction of velocity vector. In the direction of velocity vector, that is vc. Velocity vector vc. Same what it was in case of ORS system, it was m, machine reference, denoted by vm. Denoted by zm, xm, ym, and zm. M stands for machine reference system, and here O stands for your orthogonal reference system. Now we will define the various angles. Like ASA, OSA, the various angles are: number 1, inclination angle. Inclination angle. Number 2, orthogonal rake angle. Orthogonal rake angle. Number 3, orthogonal clearance angle. Number 4, auxiliary orthogonal. Auxiliary orthogonal clearance angle. Number 5, auxiliary cutting edge angle. Number 6, principal cutting edge angle. And seventh one is nose radius in mm. Nose radius small r in mm. In ASA, when we manufacture the tool, we make it in inches. But in case of ORS system, nose radius is always in mm. And the symbol that we're using for inclination angles, inclination angle is denoted by lambda. Orthogonal rake angle, I think I've already told you that rake angle is denoted by gamma, and it is as it is an orthogonal rake, gamma O. And clearance angle is denoted by alpha, as it is an orthogonal clearance angle, so it is your alpha O. And auxiliary orthogonal it was an orthogonal clearance angle. And fourth one is the auxiliary orthogonal clearance angle. Auxiliary orthogonal clearance angle is denoted by alpha prime. Prime symbol is given for the auxiliary symbol. And auxiliary cutting edge angle. Auxiliary cutting edge angle is given by phi 1, and it is equal to phi c in the ASA system. Principal cutting edge angle, it is given by phi, and it is equal to 90 minus approach angle in ASA system. This phi c and this phi s, these are the angles in the ASA system. So at 5 auxiliary cutting edge angle phi 1 is equal to phi c in both the systems. And principal cutting edge angle can be determined if it is an ASA system by 90 minus phi s. So these are the angles. Out of these two are inclination angle and orthogonal rake angles are rake angles. Both are inclination angle is also a rake angle. And whereas next two, these are the clearance angles. Clearance angles. Okay. Next. And so its structure will be likewise lambda, gamma O, alpha O prime, phi 1, phi r in mm. This is a symbolic representation of ORS system. Now we will try to define all other angles as we have done in case of ASA system. This is the reference plane pi r, and here where this is the cutting plane, as this is the principal cutting edge. This is the principal cutting edge. Principal cutting edge will give you the cutting plane pi c along axis here yo, and this is the plane perpendicular to both pi c and pi r plane, and it is the orthogonal plane pi o along xo axis, and and here now we will make all other angles visible. So this is the principal cutting edge. This is the principal cutting edge angle. Here in case of ASA system, this was the approach angle. This was the approach angle, isn't it? And here principal cutting edge angle, that is the, this is denoted by phi, last one, sixth one, phi. This phi, this phi is equal to 90 minus phi s of the ASA system. That was the phi s. And here this is the phi 1. This is the phi 1, same as, as that of ASA system. You can see that this the things. So these two angles and R we got it now. This thing we have plotted, this thing we have plotted, and this thing we have plotted. Nose radiuses, this one we have plotted. Next, we will cut the section of the tool. Here we will cut the section of the tool along pi c plane. You can see that this is the pi c plane. We cut the section of the tool along pi c plane. Then as we are cutting the section of the tool along pi c plane. Pi c plane. So here this one is the principal cutting edge. This one is the PCE principal cutting edge. This is your ZO in where there will be VC, there will be ZO. This is the YO axis, and this is the pi r plane. This will be the pi r plane, because we are cutting the section. Earlier it was your pi r plane. As we are cutting along the plane pi c, so this next when you cut it, then pi c will be the pi r. So now we got this, and this angle is lambda, inclination angle lambda. So we got the first inclination angle lambda. Next, we have cut the section of the tool along pi c plane. Now, we will again cut the section of the tool along pi o plane. We are cutting the section of the tool along pi o plane. Mm. We have cut it. So now now pi o plane, now in this case pi o plane will be the pi r plane. So this is the pi r plane. Pi r plane, and this plane is the, as usual, pi c plane. Pi c plane. So three planes we have plotted, and this is xo axis, and this is zo along vc. And this angle, this is the rake surface. This is the rake surface of the tool, and this is the flank surface, and this is the flank surface of the tool. So rake surface of the tool will give the rake angle, so it is your gamma O, and this flank surface will give you the clearance angle, so it is your alpha O. Now we got lambda, gamma O, alpha O, phi 1, phi r. Only left is our alpha O prime, or auxiliary, or it is your auxiliary orthogonal clearance angle. So for that, what we will do, we know that all the three planes are mutually perpendicular to each other. First of all, we make an auxiliary plane, like extend this, So this one, this one is this one is YO prime, and this plane is your pi c prime, pi c prime, and this plane is along x-axis. It is your xo prime, and this plane is pi o prime. Let That means first, the earlier Pisces was like this. First Pisces was like this. So we are taking auxiliary means another plane which is perpendicular to the existing one. The word term auxiliary means that. So, so auxiliary cutting plane will be just perpendicular to it. So it is your Pisces prime, and its axis will be YO prime. Likewise, this was the orthogonal plane, and auxiliary orthogonal plane will be just perpendicular to it. So it is the pi o prime and xo prime. So we have drawn the auxiliary planes, and all are mutually perpendicular to each other. Now, now what we do, we cut along the section. Now we again take cut section along the pi o prime. Cut the section of the tool along along pi o prime plane. So this was the pi o prime plane. We're cutting the section of the tool along this plane. So again, so now this is pi o prime plane, and this is alpha o prime angle. So this is pi c prime. Now we got it. So cut the section of the tool along pi o plane. We get a section like this. So now we got alpha O prime. This is this angle, alpha O. This is alpha O prime, alpha O prime. So we got all the angles. Now we'll define each and every angle. What is first is the inclination angle lambda. Here we can see the inclination angle lambda. What is lambda? Lambda we can define now. I think by this time you might have learned how to define it. What is inclination angle? The angle made by this is the principal cutting edge. Lambda is the angle made by the principal cutting edge, and the principal cutting edge with pi r plane and measured along pi c plane. I think it's very clear. And angle of inclination, it is an angle that the principal cutting edge makes with the pi r plane, and it is measured along pi c plane. Let's write down inclination angle lambda. Angle made by the principal cutting edge with pi r plane and measured along pi c plane. That is our inclination angle. Then is our gamma O. Where is gamma O? This is a gamma O. That is the orthogonal rake. What is orthogonal rake? Angle of inclination of the rake surface with respect to the pi r pi r plane and measured along pi o plane. Angle of inclination of the gamma o or orthogonal rake. Angle of inclination angle of inclination of the rake surface of the tool. You can see that this is the rake surface. Angle of inclination of the rake surface of the tool. Angle of inclination of the rake surface of the tool with pi r plane with pi r plane and and measured along pi o plane and measured along pi o plane. Number three. Third is lambda gamma o. Now next is the alpha o. Alpha o is the orthogonal clearance angle, and it is the angle of inclination of the principal flank. Angle of inclination of the principal flank with pi c plane and measured along pi o plane. So it is alpha o, angle of inclination of the principal flank from the pi c plane and measured along pi o plane So all definitions are in the figure itself. So check the figures properly and then write down. Then next is alpha, then alpha o prime, then alpha o prime, that is the auxiliary orthogonal clearance angle. So it is the angle of inclination of the it is the angle of inclination of the auxiliary flank surface from pi c prime plane and measured along pi o prime plane. You can see this angle of inclination of the auxiliary flank surface. This is the auxiliary flank surface from pi c prime plane and measured along pi o prime plane. This is auxiliary flank surface. Next is phi 1. Next phi 1, it is auxiliary cutting edge angle. Auxiliary cutting edge angle is same as end cutting edge angle of it is same as end cutting edge angle in ASA system. The auxiliary cutting edge angle in ORS system is same as end cutting edge angle of uh, ASA system. So both are same, and definition also remains same. What is that? So it is this one, this phi 1. It is the angle of inclination of the auxiliary cutting edge. This is the auxiliary cutting edge from the pi x plane. It is x plane. You see, remember this thing. See, this plane is always be pi x plane. This is pi c plane. This is pi o plane. This is pi x plane. If we draw another plane, it will be our pi y plane. But we don't need here in this case. So I'm not drawing it. Otherwise, you will be confused. If we draw it likewise, so this plane will be obviously it will be pi y plane. But we don't require in this case. So what is phi 1? So for defining phi 1, we definitely need pi x plane of ASA system. So it is the angle of inclination of the auxiliary cutting edge from the pi x plane and measured along pi r plane. The definition remains same, isn't it? So it is the angle of inclination of the auxiliary cutting edge from the pi x plane and measured along pi r plane. That is phi 1. Next is the last one, that is last angle, phi. Phi is the principal cutting edge angle. You can see that this is phi. This one is the phi. Phi is the principal cutting edge angle. What is phi? So it is the angle of incline. This is the auxiliary cutting edge, isn't it? This is the auxiliary cutting edge, and this is the principal cutting edge. It is the angle of inclination of the principal cutting edge from this plane is obviously pi x plane and measured along pi r plane. Angle of inclination, of the principal cutting edge from the pi x plane and measured along pi r plane. That is, so phi 1 and phi can only be defined in terms of ASA system. Then 7 is nose radius small r. It is in mm. So it defines here all the angles of orthogonal rake system. And there are always processes in which we can convert one system to another system. But what is the need of conversion of two angles? It is essential to understand the geometry if it is expressed in some other system. Also, we can derive the benefits of each other system. And some persons can able to understand ASA system and some person can able to understand ORS system. So when there is a conversion system is there, so that it will be easy on both the part to understand it. So this completes your ORS system.